Good morning. This is Deepti Yellanki, Assistant Professor, Haldia Institute of Technology. And today's my topic is concrete types and its tests. Coming to the contents, we would cover introduction, types, ingredients, water cement ratio, workability, different grades in cement concrete, and then finally the tests on cement concrete. Coming to introduction, what is cement concrete? See, after food, water, the next thing we depend upon is shelter. That is, we want shelter. So, for shelter, we are completely dependent on the cement because all the constructions in the world we do it with cement concrete. So, here the cement concrete, if we look into what it is a mixture of cement, sand, and your sand, which is called as fine aggregate, and the coarse aggregate, that is the stone chips, water. With this all making into a mixture, this is placed into the formwork, the skeleton into which we pour the concrete. Then it becomes stone hard. Then we carry out the curing process wherein we dip it into the water. Then it gains its strength. So this is the basic idea how cement concrete works. Coming to the plain or ordinary concrete, it is produced by by only mixing it with water and other ingredients like fine aggregate and coarse aggregate. Sometimes also we include some admixtures as per its requirement, and the instructions are always provided on the packet of the cement packing which we take. The concrete can be produced to yield a varying strength of 10 megapascals to up to 40 megapascals depending upon the purpose, what purpose you are using this concrete for. Many types of pre-mixed concretes are available, which include powdered cement mixed with aggregate needing only water. That is pre-mixed type of concrete bags. So just you need to mix water and start with your casting. So this is about your plain and ordinary concrete. Coming to high strength concrete. Now, what is this high strength concrete? Now, there are two things. You have a concrete and you have cast it into cubes. And once you're done with it, what you do, you keep it dipped in water, that is curing for 28 days. Then you find out its strength. Now the strength is very good. It is giving around 50 MPa or so, but gradually after some time it is reducing its strength. So what do you say? Is it giving good performance? I don't think so. So initial strength is high, but lateral its performance is not good. So high strength concrete has to concentrate on all these factors like long term durability, everything. So basically, the compressive strength generally is greater than 40 MPa per square inch. It is made by lowering the water cement ratio up to 0.35 or lower. Now, often we also use some silica fumes. Okay, this is added to prevent the formation of free calcium hydroxide crystals in cement matrix. Okay, this also reduces the strength at cement. This might reduce the strength, but it is on the higher side only still. Low water cement ratios are the use and the use of silica fumes make the concrete mixes significantly less workable. Now, less what is workable? Workable means being able to work with it. Means you have this ease to easily place it into the skeleton you want the concrete to be into. So, when you are able to work with your concrete easily before it attains its initial setting time or the final setting time, so that is the before the concrete loses its plasticity. So that time you should have enough in your hand so that you can give the shape, desired shape you want to give to the concrete. So that is the workability. So this can be altered using some super plasticizers, admixtures. These also sometimes add strength. So basically what we do, When you reduce the water, look now, water is added to for bonding. First of all, for bonding, the next work of water adding is to ease the process of mixing. This water, which is required to ease the process of mixing, is called as convenience water. And the water which we add for actually bond formation, the gel formation, is the bonding water. This bonding water is very less actually, okay, nearly 18 to 20%, but the other part is more actually. This water which is required as a convenience water, it also helps in reducing the heat of hydration, because cement, we know it's a exothermic reaction takes place once water is added to the cement. So a lot of heat comes out, and if we leave this heat like that, it can cause cracks. So to reduce this effect of cement, we add extra water. Okay. So the aggregate must be selected carefully for high strength mixes. Now, how well we do the packing of the matrix gives the higher strength. So, coming to the stamped concrete, it is an architectural concrete which has a superior surface finish. After the concrete floor has been laid, floor hardens, and this can also be pigmented. That is, it can be given some color and impregnated on the surface. That is, some texture can be given. It can be replicating a stone or a brick, whatever you want. Okay. And coming to the wear and tear, it is good. It is used for parking lots and all. You can see the picture here, stamped concrete. Yes. Coming to the high performance concrete now, this is what I was talking about. Performance. With strength, we also need performance of concrete to be better. It is a relatively new term used to describe concrete that is highly performing but may also have high or low strength. Now, always we don't need high strength. We may need average strength but high performance. Where we talk about performance, everything comes into picture, like the way you place that is called your workability, that is ease of placement of concrete, then compacting without segregation, like the concrete should not separate out the aggregates, water and cement. Then early age strength, this is very important because nowadays we live in a metropolitan cities and all, wherein we don't get extra time to like wait for 28 days or 1 or 2 months before we catch the next level. So early age strength is important. Long term mechanical properties, that is your strength first of all, water absorption, etc. Like for you have rains, and then again you have heat and cold cyclic loading on the structure when it is exposed to rain, summer and winter. There's a cyclic loading of your heating and cold cycles. So during this process you have these micro cracks, and when these micro cracks develop, after the next shower, what happens? Water percolates through those micro cracks, and then it gets into the reinforcement, and then you know the story, it starts to corrode, and the structure as a whole comes down. So this is important that we maintain the mechanical properties. Permeability is also important, and density, how well you maintain the density. The packing is more, the strength is more, obviously. Then the heat of hydration should be less so that there are less cracks developed. And toughness is very important so that there are no wear and tear expenses for the building, at least for 5 to 6 years at least. Volume stability is important. If there is very large volumetric changes due to heat and cold, the building is shrinking and expanding, then that is also not good. Long life in severe environments. This is again the freezing and thawing cycles which we see in extreme climates. So this also has to do something with the performance of the concrete initially we place. Coming to the bridges and all which we built, which take on the loads, high loads of the moving vehicles and all, they have to stand still there for at least for 20 to 50 years. So for that we need high performance concrete. Coming to pervious concrete, it contains a network of holes or voids, you can say, which allows air and water to freely move through it. So this won't let the water to stand on the concrete and spoil it, and it easily percolates through the concrete. And how we do this actually? We add some admixtures which artificially create some air bubbles, and these air bubbles, wherever it is it is like it lasts only for some time, till the concrete has attained its initial setting time, and then these air bubbles are gone. Once they are gone, those air gaps are created wherein the water percolation can easily take place. Coming to roller compacted concrete, this is also called as rollcrete. It is a low cement content stiff concrete placed using techniques borrowed from earth moving and paving work. The concrete is placed on the surface and is compacted using large heavy rollers, typically used in earthwork. We have seen rollers and all, right? So, using those, these concrete are actually made into a monolithic body, which actually can take a good amount of load. So, this is about the roller compacted concrete. You can see how it is actually done at the site. You can see how it is rolled. The concrete is rolled. Coming to the glass concrete. This is old technology actually, the recycled glass as aggregate we use in this, and it gives a very beautiful look to the concrete, aesthetic, appealing look. And recycling of the used product is also there, and thermal insulation is good in this due to the thermal properties of glass aggregate. Coming to the rapid strength concrete, this type of concrete is able to develop high resistance within few hours after being manufactured. The feature has advantages such as removing the formwork early and to move forward in the building process at the record time. Basically, the formwork wherever is like they can't afford to get lots of formworks, they use this rapid strength concrete wherein they can remove the formwork early and start with the next bay. Limecrete or lime concrete is the concrete where the cement is replaced completely with the lime. And we know initially lime was used for construction, and in cement also the major percentage, that is 65 percentage of its chemical composition is lime. So that is the basic binding property comes from lime. So we can do this. Lime can be replaced with cement, and where not lot of strength is required, just basic interior flooring and all, we can use this. So limecrete is a mix of natural hydraulic lime and sharp sand. Sometimes glass fibers are mixed to give a more durable surface. Coming to the green concrete. Now, what is this green concrete? As we have already talked about, cement being the only thing used after food and water. So, its third largest consumption is there all over the world. So, we are all dependent on cement, and for production of cement, we are completely dependent on limestone. And one more thing, the limestone is getting depleted day by day because that is a non renewable resource. So, for this problem, we have to look into envisage new alternatives to lessen our dependency on limestone, number one. And one more thing is for production of the cement, for production of 1 ton of cement, we release around 1 ton of CO2 into the atmosphere. So that is also not very desirable for today's world. So for all these things, people are now looking into better opportunities into concrete production, cement without cement. So if we want to replace cement, we have to replace with something which has properties similar to cement. Cement has lime, the other things should also contain lime. So, after looking into all the waste which is already generated by the industries like your fly ash, slag, so there are some pozzolanic materials available, rice husk, many. So all these pozzolanic materials, basically what is pozzolanic material? Pozzolanic material is by itself, it's not a binder, but when it is reacted with the activator, it behaves like a binder. So that is what we want for the reaction to carry on. The aluminosilicate gel which forms, it binds all the aggregates, fine aggregates and coarse aggregate together, and once it hardens, then it is a structure. So that is where geopolymer concrete or alkali activated concrete came into picture. So this is about green concrete. You can see how it looks like, green concrete blocks. Now coming to the ingredients of the concrete, four main ingredients which we have already seen: cement, aggregate, steel, water. The aggregates, they are inert, chemically inert, because they should not react with the mixture, so that they stay inert and give strength to the structure. Two categories, that is fine aggregate and coarse aggregate. The material which is passed through BIS test sieve 480, that is 4.75 mm, is termed as fine aggregate. Usually river sand used as the fine aggregate. Coming to the material which is retained on VIS test sieve 580, termed as coarse aggregate, which is broken stone, generally used as coarse aggregate, and all the other factors which we use for walls, slabs, everything. Okay. And one more important rule for this is the thin slabs or walls which we cast, the maximum size of the coarse aggregate should be limited to one third the thickness of the concrete section. So likewise, there are some rules we use to do the sieve analysis, do the gradation, and then we use the fine and coarse aggregate depending on the depth and thickness of the member we are going to cast. Coming to the steel reinforcement, there are many types of reinforcements available depending on the requirement of the structure. The diameter of the bar vary from 5 mm to 40 mm. Sometimes the square bars or twisted bars are used as per the requirement. Road slabs and other construction also we use this. Coming to the water, it is the least expensive, we say, but in some cities, yes, it is very expensive. The water which is used for making the concrete should be clean and free from harmful impurities such as oil, alkali acids, etc. In general, the water which is fit for drinking should be used for making concrete. Coming to the admixtures, it may be noted that sometimes the ingredients other than cement, aggregate, and water are added in concrete to give it certain improved qualities or for changing the different physical properties in its fresh and hardened stages. Okay, so these ingredients are called as admixtures. It may increase the setting time or reduce the setting time. It may be increase its workability, strength, hardness, water resisting power, etc. And these are some of the common admixtures used: alum, aluminum sulfate, barium oxide, bitumen, calcium chloride, coal ash, common salt, iron oxide, lime, mineral oil, organic oils, many more. Okay. And some of the main types of five categories of the admixtures used are accelerators, which speed up the setting time, mostly used in tunnel liners and all. Coming to air entraining admixtures, which we have already seen, and high range of water reducers or super plasticizers, we call them. Normal range of water reducers or plasticizers. Then comes the retarders. Retarders are basically the admixtures we use where the mixing site and the placing site is far away, so we use it to reduce increase the time of the setting. And coming to the advantages of using this admixtures: adjusting the final setting time of concrete, higher early and ultimate strengths, higher slump and self-leveling concrete, increasing durability of concrete, lesser water cement ratios, reducing the quantity of cement, reduction in the permeability of the concrete, time saving in terms of repair and maintenance. So we will continue the rest in the next lecture. Thank you very much. Keep connected.